saw YouTube. When I disassembled the rear axle, I discovered the original drums, they were in bad shape, they have cracks, and they were oversized. So I start shopping online. I find one of them at Doro Brake. They couldn't locate any other one, they only have one. The salesperson over there, he told me they have these drums, they bigger. The original one, they used to be 5 inches. These, they support 6-inch shoes. He sent me the drawing of the original drums and these drums. And I made a jig with all the sizes of these drums, and I try them to make sure they will fit on the wheels, the whole pattern and everything. And according to the drawing, they should fit on the wheels. After I finish the repair, I try to install these over here, this shoulder in some area, because this is not perfectly rounded. It has little bit wobble when this rotate. The high area will hit the wheel and doesn't allow the back portion of the wheel to seat all the way. Maybe by about 3/16 of inch. I contacted Doro Brake and I asked him if there is any solution, because this dimension, it doesn't match their drawing. And as you see, the area over here is narrower than this one. The measurement is supposed to be 1.42 inches. This one measures 1.25 inches. They were good. They gave me a partial refund. I went to a machine shop. They have larger lathe. My lathe doesn't support me machining these drums. There is a lot of meat. I actually could remove some material from these drums and the wheel will fit on them perfectly. However, I don't have large lathe. Originally, when I was shopping for these, before I bought them, I went to a machine shop to cut them right here so they will fit and I could use them as 5-inch drums. The machine shop, they want to charge me $600 just to cut 2 of them right here so they will fit. And I thought they could do this repair for same price. However, when I went again after I discovered this issue, they want to charge me $1,000 to machine little bit material from here and from the other side. I thought about building a lathe over here, something stationary, and I could move it in both directions, and I use carbide and use the engine power, and I could machine little bit out of this until the wheel will fit. However, this may be not rigid setup and it may cause chattering. So I decided to make 2 spacers so I could put them between the drum and the wheel to space the wheel out just little bit so I could install them. In the future, if I buy bigger lathe, then I may remove these and machine the surface so the wheel will fit perfectly. I'm one of those guys who against use spacers, because if you set your wheel further than the bearing, this may cause damage to the bearing. However, I'm thinking about going only about 1/4 inch to 5/16. This is a 3/8, so I may be able to machine little bit out of it, or I may just leave it to 3/8. I think I have a plenty room, and this just little bit area, or a 3/8 of inch, around 1 centimeter, is not gonna cause a lot of issue. And I could machine that on my lathe. This needs to be 11 inches. I could set up my lathe to be able to machine this, and I could make 2 spacers. And I'm going to do that at the house because my lathe is at the house, and I'm going to make 2 spacers, one for this side and one for the other side. I hope you enjoyed this video. I marked and I cut both blades to oversize. I'm going to machine them on the lathe to the size I'm looking for. The measurement from the two old drums and the two new drums, it vary by little bit, but all of them measure little bit over 11 inches. The inside of the wheel, the flat area where it's going to register on the drum or on this, it measures 11 and a half. So this needs to be under 11 and a half and over 11 inches, so everything will work perfectly. The inside dimension or this cut need to be precisely 6 1/4, so this will register on the wheel hub and it doesn't cause this problem. The way I'm going to machine these on the lathe, I took the 8-inch 4-jaw chuck, installed it on the lathe. I brought this 8-inch pipe, I cut it to 4 inches and I hit it with the wire brush on the grinder so it's very clean and the chuck will clamp into it real good and it doesn't come off or it doesn't cause any issue. And then I machine this surface. This surface right now is perfect. If I put dial indicator on it and I rotate this, it will read 0 all the way around. The way I'm going to machine these, I'll set it like this. I bring the tailstock with the live center and I use the live center to clamp this against the pipe, and then I bring the welder and I tack it in multiple locations so the chuck will drive this piece and this piece will not come off. And after I cut both of them, I will take them, clamp them to the old drum and transfer the holes to this so these will fit on the studs. Also, when you machine on the lathe, you need to be careful. If the metal hot, it will expand. So if you cut this to 6 1/4, then remove it from the lathe, and then it will cool down. This may not fit on the wheel hub. So make sure the temperature of this doesn't get too hot. Make sure it's cool before you remove it from the lathe. And now I'm ready to start this work, and I'll show you everything. I'll bring the camera, show you the dial indicator, and then I'll show you how I weld it, and I'll give you a few tips when you weld something on the lathe, what the proper thing to do. I am ready to weld these two parts together. It's very important when you weld on the lathe to connect the work clamp directly to the work. Don't connect it to the bed or anywhere else on the lathe, because the welding process will generate high current and this may cause arcing on the bearings, gears, or the machine surface of the lathe, and this will damage it permanently. So make sure you connect this to the work. Also, try to protect as much as possible so you don't damage the machine surface of the bed and all these parts. I'm just going to use scrap sheet of metal. I'll tack it in a few spots, then I'll keep move this around. I put 4 welding tacks in line with the chuck jaws. I want to make sure this not going to hit the saddle of the lathe, and it will clear. I still have about 120 thousandths of inch to go. Perfect. This dimension is done. I grinded this tool especially for this job. I'm going to set the lathe to the slowest speed. I am going to cut it with this tool little bit smaller than 6 1/4 inch, and I will use different tool to machine it out until I have 6 1/4 precisely. I'll put little bit relief over here so it will break the chip easy and it doesn't chatter. I'll make it a little bit thinner, that may help. I need to machine about 1/4 inch out of this. It's about 4/1000 of inch shy from 6 1/4. I'll wait a little bit, make sure this is cooled down, and then I'll take measurement, and if I need to, I'll do a final cut, sand it a little bit, and chamfer it over here, remove the sharp edge. It's been about 30 minutes, and it's cooled down. It's zeroed. It's still read about the same. It's about 4/1000 of inch shy. I'm going to take a very light cut on auto feed. It is perfect. Maybe 1/2,000 shy. I will sand it little more, and then I will cut it and remove it from the chuck. Perfect. It's exactly the same dimension as the other piece. The way I sharpen this cutting tool work out great. It cheddar a lot, however, it worked and it did the job. I grind it in a way to take the form of the circle. In the beginning I have it thicker because I was worried about it breaking. However, I had to thin it so it doesn't cheddar bad, and it worked great. I also sharpen it at this angle so when this come off, it will take this shoulder with it, and it will leave a clean surface over here. Perfect. It's exactly 6 1/4. I used the wire brush disc on the grinder and I removed all the rust from the machine surfaces over here, and inside. And then I took some sandpaper and I cleaned these holes. I also took the grinder and used the grinding disc and I grinded this welding tab I used when I machined those on the lathe. The pilot hole is perfect. They line up perfectly. And as you see, the outside too. The 4 drums that I have, the 2 old one and the 2 new one, this measurement will vary. On this one, it's 11 inch and 60 thousandths of inch. When I machined those, I made them 11 inch and 95 thousandths of inch. They fine, the wheel will fit on them perfectly because the wheel, a flat surface from the inside, it measures 11.5 inches. So the wheel will fit perfectly. Now I'm ready to transfer these holes to these 2 blades. I have good idea on how to do it. I'm going to set these perfectly in a line with the drums and then I'm going to clamp them. And I'm going to make a plug on the lathe so I'll be able to transfer the holes from the drum to these new blades or spacers. These will not fit from this side because this over here is smaller than this. So I have to set them from the outside and drill them from the inside. These holes, they vary because when they drill these, this is cast iron and they use drill brass. And the drill will wobble. So these holes, they're not precise. They measure on the old drum about 0.840. They vary by little bit, by about 7 to 8,000. On the new drums, it's about 0.850. Little bit less than 7/8 of inch. I have 2 drill bits. One of them is 7/8 and the other one is 25/32. The 7/8 will not fit. It's little bit big by about 25 thousandths on these holes. The 25/32 is little bit small. And it's about the same size as the stud on the machine. So I'm going to drill them on the final drill bit. It's going to be the 7/8 drill bit. And now I'm going to show you how to make the plug on the lathe. This is a piece of 1 1/4 cold rolled round stock. It measures about 1 3/8 in length. I'm going to make it to the same size as the smallest hole, which is 0.842, which is right there. Depth wise, it's exactly ½ inch. I need to go a little more. I need it to fit as much as possible so it will register perfectly. Perfect, about 10,000 shy. I just need to remove the sharp edge. It fit in all of them perfectly, and it's about 10 thousandths of inch shy over here. So I could push it all the way in. I'm using this parallel as straight edge. It's perfect. Still good. I am going to use the same drill bit I drill this with to transfer the hole center. When I drilled these pilot holes on the manual drill using this block, I made sure I go down about 1/8 of inch. This way when I set it on the mill, this drill bit, it's the same drill bit, it will register over here so I get it indexed perfectly. The way I'm going to do it, I'm using this 1/2 inch stock as a spacer. When you drill using the milling machine or a drill press, this has 1.5 horsepower motor and the pulleys will increase the torque. So make sure your hand is nowhere to get in a bind if you try to hold a piece while you're drilling it. So I'm not going to use my hand. I'm going to clamp these to this block of wood while I'm drilling it, just in case the drill bit bite. And if I'm holding this with my hand, this may cause an issue. If it's got in a bind, the drill bit, and this try to twist, it's gonna hurt me. So I wanna make sure my hand out of the way. I'm going to use the drill bit to index the hole. As you see, the drill bit go on the center of this hole. And now I'm going to drill it. I'm going to drill it with this number 7 drill bit. And then I go with 5/16 drill bit, 1/2 inch. And finally I'll drill it with the 7/8 drill bit. I originally thought the final step into machining these two spacers is to chuck them on the lathe and machine this surface and machine this other surface parallel to it. However, after I chucked it on the lathe, when I tied the chuck, they will flex and they will give me different reading if I rotate the spacer on the chuck. I'm not going to machine them because if I machine them in this current setup, the tool will cut more in the supported area by the jaw of the chuck, and over here the tool may push it and cause it to be wavy. It's better to leave them like this. I'm just going to sand them and deburr these holes. I'll deburr the hole first and then I'll sand them on the lathe. When I check them with the micrometer, they vary by about 0.5, and that's because they painted and they may have scales or rust under the paint, so I'm not going to machine them. I think they're better the way they are. The jaw of the chuck is stick little bit below this plate. Further down there is this over here, these tabs, so I'll try when I sand them to keep my fingers away from those. Also the lathe has this inching button. When I press it, the lathe will spin. When I let go, the lathe will stop. It will be safer than turn the lathe and leave it on. On the way here this morning, I stopped by auto store that sells parts for equipment like this, and I was shopping for buds with the thread start right away. The original buds, they still in good shape. However, as you see, the thread will not start till about 1/4 inch to 5/16 of inch, or little bit less than 1 centimeter. And I'm worrying if I use these buds and this spacer, I'm only using about 3/4 of inch of these studs to hold the wheels. They have these buds, they're little bit taller than the original, and they have this shoulder. If I machine this shoulder off to the edge to match the original one, I'll be able to use the thread or all the thread inside this bud, and it will start right away from the edge. And this will give me the maximum clamping force on these studs. And like, I didn't use these spacers because these, they have about the same thickness as the spacers before the thread start. And if I machine those, then the thread will start right away, and I'll have about 1 inch of a thread, and this should be strong enough to hold the wheels. And now I'm ready to try to install the spacer on the other side. Perfect. It's tight fit. I have little bit of play on the thread. It doesn't move side to side. It's registered real good on the wheel hub. I am ready to machine these buds, 6 of them right hand side and 6 of them left hand side. I will chuck one of the old nuts for the right hand side on the lathe and screw this bud on it, and then I'll machine it from here. And the other 6, I will chuck a left hand side nut, and then I will rotate the lathe to the opposite direction, and I'll machine them from this side. Because if I try to machine these from here, they will loosen itself and they come out. I'll show you how to do that here in a second. I also thought about cut this with the grinder. On the lathe it will be better. But if you don't have a lathe and you have to add the spacer, if they fabricate those, I don't know, some factory may build those for you, and you buy similar studs, then you could just cut them on the grinder. And as you see, the thread on this one will start right away. And this will compensate for the thickness of that spacer I made. As you see, if I try to hold it or cut it with the tool this way, when the chuck rotates, it's going to lose itself. I will do the other 4 left one off camera, and I'll see you by the dump truck. I tested the buds on both sides and they thread very easy. Also, when I machine them to match the original buds. And when I install these, they are lower than this surface by about 1/8 of an inch. And this will allow me to torque the wheels all the way against the hub, and I don't have to worry about this wheel walk itself loose and damage these holes. And now I'm ready to install the wheels on both sides. I am going to apply anti-seize on the studs so I could torque the buds very easy. And in the future, if I have to remove them, I don't have to worry about them seizing on the stud. perfect. The shoulder of the drum doesn't hit the wheel. I have about a 1/4 inch clearance between the drum and the wheel. I will install these buds on both sides, and then I will show you the clearances that I have. And as you see, I have a good 1 inch of a thread to tie the bud against the stud. I have plenty room between the drum and the wheel. Before I build these spacers, the wheel over here will touch the shoulder of the drum. I have to run the generator to recharge the air compressor. This tool, it uses a lot of air. I painted these wheels about 3 weeks ago. If you paint your wheels, spray them with some type of lubricant, like silicone lubricant, so they don't stick to each other. It will take a long time for this paint to dry. I'm torquing them on the second setting or the middle setting. Left for this side and right for the other side. Both sides, the wheels are spinning through. The original 5x15-inch brake drums, they were in bad shape. And I couldn't find the exact match. That's why I have to go with the 6x15-inch because I found two of them and I bought them from Dora Brake. When I bought the 6-inch brake drums, originally I thought to machine about half inch out of them to be able to use them on the existing backing blade. However, the machine shop, they want to charge me $600 to do that. I was able to redesign the backing blade and use 6-inch shoes, and I was able to use the brake drums without any modification to them. And I saved a lot of money. I posted video about how I redesigned the backing blade. The 6-inch shoes actually cheaper than 5 inches. I shopped on eBay and the 5-inch they cost about $200. The 6-inch they cost me a little bit over $60. So I saved a lot of money there. By making these spacers, I saved $1,000. The cost of the scrap metal that I used to make these spacers and the bud was a little bit less than $60. So I saved a lot of money. There will be a lot of video coming on this channel. Mechanical work I did to the engine and some body work. I repaired the cab and a few other rusted spots. And I also painted this truck. So whenever I edit these videos, I post them on YouTube. Please, if you want to support this channel, like, subscribe, and comment so I know people interested on this content so I post more video about this type of projects in the future. I hope you find this video informative. Thank you for watching and thank you for your support, and I'll see you later.